So the problem we've been presented with involves surface mining drill rigs. The current systems are overheating, and in some cases thermal cracks have been observed throughout the radiator. So we've been tasked with designing a subscale prototype that helps to keep the systems cool in varying environments and also helps to reduce the thermal gradient and prevent thermal shock of the system. So when we were first presented with the problem, we thought that we could just try and tackle the algorithm, tune some of the gains so that it performs better. We started looking into being able to actually control the flow in the system. We began looking at valves in combination with tuning the algorithm. The first thing we did is we started doing research on the type of controllers that we could use. Then we started doing research on the valves that we could use. They have to meet certain criteria. Obviously, they need to be able to withstand temperatures below freezing, -40 degrees, and also temperatures above 220 degrees. We bought a freezer. The freezer kind of houses all the components and allows us to, again, mimic those ambient temperatures because of the insulation properties. We used a radiator similar to what they have, obviously scaled down for the subscale prototype. We had to design some circuitry here to be able to read the different temperatures moving through the system. So we built, a circuit design with a couple thermometers that read internal and external temperature. We also designed a fan grid to actually cool the liquid moving through the system. And then we used a valve that we could control to manually move the liquid through the system at varying percentages.
The bucket on the right houses the 3070 glycol solution. We use an immersion heater to add heat to the system prior to it moving into the pump. We then direct flow from the pump into the manual valve where we can control the amount of flow moving into the radiator or bypassing it entirely. The liquid that moves into the radiator is cooled and moved back into the pump where it's mixed with the liquid bypassing the radiator. The goal of our prototype is to measure the amount of cooling we can get by diverting liquid into the radiator and how much heating we can get by diverting liquid away from it. The more liquid that moves into the radiator, the more cooling we get. The more liquid that bypasses the radiator, the closer we get to the constant heat addition by the immersion heater in the bucket. By controlling fan RPM and valve actuation, we can keep the prototype closer to the set point, reduce the chance of overheating, and reduce the overall thermal gradient in the system.